Hello everybody and welcome to this video in the bug bounty course. We're still talking about bug bounty basics, but today we're going to talk about how the internet works and kind of the underlying technologies that make what we call the internet and the web even possible. And it's really important to understand that because it's really hard to contextualize a lot of web security vulnerabilities if you're not really sure some of the language that's being used. I see this a lot when I look at things like request smuggling that are really technical bugs and kind of require quite a lot of back-end knowledge, that people really want to learn these bugs, but because they don't have the prerequisite experience with the fundamentals, struggle with it. And also because I think it's a really great place to start. So today we're going to be talking about really how this all comes together and how a website gets produced. But first of all, we've got to thank our series sponsor. This series is very kindly sponsored by BugCrowd. BugCrowd is the best place to get started hacking with a wide range of public and private programs from APIs to desktop applications and everything in between. Not ready to jump into a public program yet? Fill out your platform CV and sign up for a waitlisted program. Tell BugCrowd a bit about your skills, previous certifications or experience, and they'll match you up with the right program using their industry-leading crowd match technology. Whatever your level, there's a place for you in the crowd. So thank you very much, BugCrowd, for sponsoring this video. The inspiration from this video really came from this tweet by Rhinerator back in November last year. So Rhinerator was one of my mentors when I really first started doing bug bounty. He's a fantastic mentor, fantastic hacker, and he had this really interesting idea of what prerequisite knowledge for bug bounty hunting might look like. So he was talking about, what happens when you type in a URL into the URL bar, how does DNS work, how does TCP work, what is an HTTP request response, script, link tags, etc. So he mentions trying to understand how the internet and web works first before you dive deeply into web security. Now, this isn't to say you have to know this. The point is it gives you that contextual background information. So that's what we're going to do today. We're going to talk about how this kind of fundamental technology works. So first of all, let's talk about the internet. So the internet is the global connection of devices over a protocol called TCP/IP. Now, it's not really important how TCP/IP works. I will talk a bit about it, but the idea is that there is a handshake, so the two computers know they can talk to each other. That then allows for further communication, and it tries to lose as little information as possible. So essentially, it's the networking protocol the internet uses. TCP, so this is a service that uses TCP/IP to interact and display websites. So HTTP is like the service. On top of that, you have web servers, so they implement HTTP, but can be written in whatever programming language, it doesn't matter. And then you have a request and response. So request is a structured piece of text that's sent to an HTTP server, and the response is the reply to a request that your web browser then renders as whatever visuals. So the TCP/IP handshake, you send the server a SYN, they send back a SYN-ACK, like, yes, I can hear you, and you send back an ACK. And there's a bunch of things with how things like port scanning work and abuse the TCP handshake. But essentially, it allows two computers to talk to one another. DNS. When we think about how we connect to computers on the internet, we don't use IP addresses. When we access websites, we use something called a domain name. So that's google.com. That's insiderphd.dev. That's twitter.com. Different domains go to different IP addresses. You can also have subdomains, mail.google.com. So fundamentally, because we're using TCP/IP, we still need the IP address. It isn't enough to just have a domain name. We also have to know what computer that's connecting us to. And DNS is the bridge between the two. It provides a kind of big phone book saying that domain name is connected to that IP address. And to do that, it uses a series of DNS queries. So let's assume a user wants to access insiderphd.dev. So first, the request is sent to a recursive resolver owned by your ISP. So essentially, you ask your ISP, hey, do you know any information about insiderphd.dev? What's the IP address? But we need to find what's called an authoritative name server. So we need to find the people that own .dev. Then we go to a root name server, and it kind of sends us onwards and says, okay, I'll try asking them. And it will be able to point us based on the TLD. So that's the final part of a domain name, .com, .net, .dev, UK, etc. Now, once we access that, it will say, oh, you're looking for a .dev. You need to access this name server. So then we go to the .dev name server, and then we can look up inside a phd.dev. And then when we find that, it will say, oh, the authoritative name server for that domain name is actually Namecheap. So that's the actual DNS that you set, is that authoritative name server. So your computer talks to your ISP, they go to the root name server, then they go to the top level domain server, and then they go to the authoritative name server, and finally your computer can say example.com is located at IP address whatever 888. And then if you look up the actual DNS queries, this is the result. So here we can see that inside of phd.dev has what's called a type A record that points it to this IP address, 198.154, etc. It's owned by Namecheap. They host it for me. So this domain name is linked to this IP address. There's a bunch of other types of DNS records that you can have. So you can have A records, which is an IP address. A records, which are an IP address but in version 6 form. A CNAME address. So this is an alias to another domain name. MX, which is email, NS, which is the name servers. There's also reverse IP lookups. So if you have an IP, you can see what's being hosted there or what's pointing to it. Text, which allows you to put anything in here. This is my text record. And you can see I've got a security contact text record, which talks about the domain's authority. And actually you can look these up for any. I'm going to leave this in the description so you can take a look yourself. But this is a website that you can just put in any domain name and see what the records are. So great. We found the IP address. What happens next? Well, once we actually know where we're supposed to connect, we can actually start to talk to the web server. So all web traffic is handled by the HTTP protocol. HTTP usually runs on port 80 and your browser will add this automatically. So every single time you go to google.com, it will actually add a port 80. Or if it's HTTPS, add port 443. So you will never see that. You may see it if you're looking at like weirder ones. So port 80 is automatically added, but you might see 8000 or 8080. Unfortunately, with HTTPS, we have encryption. So this is what it looks like when you spy on HTTPS. You can see where it's going, see that it's HTTP, but you can't see any other information about what's actually being sent. Which is a problem because that's how you hack stuff. Like we can try and interact with the web browser and try and hack with the web browser, and certainly people find bugs that way. But it's just not the best way to do it. So HTTPS, and this is why anytime you see people saying a VPN will solve all of your problems and you won't get security attacks, everything is encrypted. The VPN doesn't solve that problem. We need to cause what's called a man-in-the-middle attack. And to do that, we're going to install a certificate with burp called a CA certificate. So this is where the proxy sits in. So in order to actually see the HTTP requests, we actually need to use a tool called a proxy. A proxy will handle requests on our behalf and allow us to change them or resend requests with different data. And there's a bunch of other cool tools that these often have. I always think of them as like an IDE for hacking. In the same way, a web developer will use a JetBrains product, for example. So the most common proxies in the community are burp and OWASP Zap, with a lot more people using burp. Though Kaido has only recently gone into beta, I know a lot of people are really excited about that. In this series, we're going to use burp, but it's not for any other reason. It's just the most common. And certainly if there's demand for it, I will make videos on all of the other. So HTTP uses what's called a request response lifecycle or structure. You send a request to the server and the server sends you a response back. The response cannot exist without a request. And it has this nice envelope structure. So it starts at the very top here. These are all the headers. So you can imagine like an envelope. This is your address. And then at the very bottom here, this part is the actual body. So that's what your web browser is actually rendering. Up here, you can see the method being used. So this is a get request, but you can also see a post request and an options request. If you're hacking an API, you'll see put and delete. And if you're trying to debug things, you might see head, connect, trace, and patch. It's not really too important what the differences are here because it tends to be quite specific, especially when you start talking about like APIs. So we're just going to very quickly have a look at the two most common ones in a second. So request type, get. It's usually get or post. This part here, this little slash, that's what's at the end of your URL. That's the endpoint. Endpoint just means somewhere code is. In the host, this is the domain you're accessing, so google.com. We have some cookie that's going to allow us to retain some state. Some information about our web browser. Accept here shows the web server, hey, this is what I can accept. And then there's a bunch of other like security headers and stuff. For the response, we get a little code to say if it's worked, so 200 is okay. We have some information about what content it sent back, so this is text HTML. Now, if we have a look, so then we have some information about the content it's actually sent back, so we have text/HTML, but actually if we go over to this side, oh look, we can accept text HTML. This is how your web browser knows what to do with the data. So this actual data down here, for our case, it's HTML, but if that was like an image, it would just be like text. And then the content type would say, hey, this is an image. There's also information about the length, and again, a bunch of other security headers. So status codes. HTTP can return a lot of different status codes. So 200 is a success, 300 is a redirection somewhere else, 400 usually means that you've made a mistake, for example, trying to access a file that doesn't exist. A 500 error tends to be when the server has made a mistake. So in 400, you're likely to see unauthorized errors, forbidden errors. You need to log in to do that. You need to have permission to do that. The 500 errors usually means there's an error that the server won't show you for whatever reason. So it might be a kind of more generic error, or it might be actually the point of what you were trying to do in the case of things like application level DOS. So HTTP headers, here are some of the most common ones you'll see. The host, which is the domain name. You'll see the content type /accept, so the type of data that's being sent and received. Authorization will be one method of authenticating users and showing, hey, I have permission to do this. Cookies /set cookies, they allow data to be stored on a user's device. The user agent shows the device the user is using. It lies though, you can't really trust it. It's just plain text. And then we have some other headers. So important ones are things like the content security policy and the access control origin policies. This is often called things like the same origin. Now these provide specific security features, such as only allowing specific hosts to make requests. So in terms of what these offer, these we're going to talk about a lot more when we start to cover it. But these, again, it will implement some security controls at like a browser level. So the difference between a get and post request is really that in a get request, the parameters are in the URL, and in a post request, they're in the body. So you have to look for these at the very end of your request. And so here you can see when we post to this URL, the data is being stored in here, but we can actually see it here. And that's the only real difference. What you'll tend to see is the post requests are used when you send data. So if you're sending a form, it will be a post request. If you're not, it will be a get request. So sessions and cookies. So sessions are stored on the server. Cookies are stored in your browser. Sessions are deleted when your web browser closes, and cookies can be stored for a long time on your computer. So LogMe uses sessions, but Remember Me will add a login cookie to your set cookie. Those cookies will then start a new session on the server when you come back. Again, something we're going to cover in way more detail, but it's worth saying here, if you don't press log out, assuming you have the session information, so things like the session ID, you can still access the website. And this is what it looks like. So the first request I sent to yahoo.com has nothing, and the second request onwards has a bunch of random data. So HTML, CSS, and JavaScript, your client, like your web browser, never sees the raw backend code that the developers have written. Instead, it gets mashed and processed into this client-side code. So if you want to think about it like a house, HTML provides the structure. So that's almost like the house plans. It's saying, hey, there's a living room, there's a kitchen, they've got doors that connect to them, there's some stairs, whatever. Now this is called the DOM, the Document Object Model. You then have CSS. So CSS provides the styling. That you can think of that as like what color bricks they've used, have they painted it? What do the window trims look like? Not important to like how the functionality works, but very important for like how the visuals look, right? If you just had the plain HTML, you wouldn't be able to tell anything apart. You then have JavaScript. So JavaScript provides interactivity. So it defines, hey, you can open doors. Hey, you can open windows, etc. Your browser actually computes all of this into a website. Now, JavaScript, by allowing interactivity on a page, it avoids the requirement for a web page to have a request to change. JavaScript is run on the client side and it can allow that DOM to change. It can also make requests and receive responses in the background as well. As you can imagine, this is actually quite a big security issue because this is essentially untrusted code that is being run on whomsoever's computer. Now, I'm not going to get too into the kind of like how web browsers work, because that's called browser exploitation. I will leave in the description a link to some of the videos that Live Overflow have done, which is really, really good on this topic. If you think about any complex web apps, Gmail, Yahoo Mail, Outlook, you can do a lot without it refreshing the page. And like a lot of elements can be created and things can pop up and go down, etc. So there's actually quite a lot of code that's being run to make that possible. So your homework for this week is to download and set up Burp Suite Community Edition. You don't need to pay. Buy it with your first bounty. I did a challenge last year where I didn't pay for Burp Pro and I was able to find plenty of bugs without it. And I was able to easily make enough to pay for Burp Pro if I wanted to. You really don't need to pirate it. Firefox, if you don't already have it, and install Foxy Proxy and then set up Burp on Firefox or use the built-in browser on Burp Suite. And that's because next week we're going to be talking about how I get set up for hacking and some of the ways I use Burp to actually help me hack and looking at kind of my setup. So thank you very much everybody for watching. These videos are coming out weekly, so I will see you all next week. They always come out weekly on a Sunday, same time, and next week we're going to be talking about Burp. So have a good week, everyone, and I will see you all in the next one. Bye, everyone.